Hi everyone, I'm Brian Cox. In this video, I'll show you how to build my soldering kit called the Demonstrator. You can use this video in combination with the printable instructions available on my website, and I recommend you go through the instructions and watch this video before starting your build. Now, the electronic parts in your kit are organized by their value, and many parts look the same. I highly recommend that you keep all parts in their respective bags until you're ready to use them. Also, in this video, I'm assuming that you already know how to solder. If this is your first time soldering, then I recommend you start with my Soldering Basics kit, and the videos for that kit provide detailed instructions on how to solder. All right, let's get started. Now, I'll be using a circuit board vise from Weller, which has a built-in sponge to hold parts in while you turn the circuit board over to solder each part. But I'm going to show you how you can also hold parts down using a little bit of masking tape, or simply by moving the leads slightly away from each other or splaying the leads to make sure that they stay in place when you turn the board over. In this video, I'm going to follow the steps exactly like they appear on the printed instructions, and we're going to start with the resistors. Now, in order to properly install the resistors, we're going to use a lead forming tool, which helps you bend the leads on the resistors. This is included in your kit. What you do when you use this tool is you first line it up for a resistor location to determine your spacing. And it turns out that the third space down on the lead forming tool is what you'll use in order to properly bend your leads or form your leads. Here's a quick demonstration on how to use the lead forming tool. We determined that we want to use the third space down. So what you do is lay the resistor right across the middle valley and then hold it with one finger and then gently bend the leads down on both sides. The leads then should be going straight up and down. So now you can see, now of course I can make that a little more straight, but just to show you, that's how we can form the leads. It helps us have a much cleaner bend and make sure that there's an equal amount of lead on both sides of the resistor. When installing parts on a circuit board, I like to start with the parts that lay closest to the board first, and then build taller and taller parts from there. So we're going to go through and do all of the resistors first. We're going to start with the 620 ohm resistors, which their color code, by the way, is blue, red, brown, gold. Remember, when you're reading resistors, you always put the metallic color towards your right. When you install the resistor, you want to be able to read the color code the same direction of the value that's printed on the circuit board. So we'll put gold on the right as well. Now the numbers again are R1 through R10, and then R12 through R20, and you can see the values printed here. So I'll show you how to install one and how to solder it, and then I'll show you what the section of all the resistors in this row look like when they're complete. Because we formed the leads using our little tool, it slides right into place. What you want to do is hold the part with your finger and turn it over, and then I'll hold this so that you can see, and then as you're pulling slightly on the lead, bend the leads away from each other. And now you see the part stays in place. Again, we want resistors to lay flush against the circuit board. Now, as I mentioned, with my Weller tool, I can also bring my little sponge around and hold it in place, but I find resistors stay put quite nicely by splaying the leads slightly away from each other. Now, remember, when you solder, the goal is to heat the lead and the pad hot enough so that it will melt the solder for you. You want to feed the solder onto the connection between the pad and the lead, not actually onto the iron itself. So let's get these two parts soldered. Just a reminder, when you solder, the solder should go all the way around the pad and slightly up the lead. So the first resistor is ready to go. I'll go ahead and finish this entire row all the way across. Quick note about parts like this, these resistors often will come in their little belt-fed tape, which is how the machines feed them when they're stuffing the circuit board. In order to take the part off of this tape, just peel it from the end. I find it's good to hold on to the actual body of the resistor and just gently pull away so that the tape comes off, and then you can do the same thing. It'll pull straight out. And I recommend just going through and untaping or removing all of the resistors before you start building. It'll help you save some time. So here are the first 10 resistors ready to go. Before I trim the leads on the back, I'm going to double check and make sure that this is indeed a 620 ohm resistor for every single one. Make sure that they're laying flat and making sure that they're in the correct direction. Now, when you trim the leads, use diagonal cutters or flush cutters and leave about 1 to 2 millimeters of lead sticking out from the solder. And I like to keep my finger here when I trim them so that the little leads don't go flying. So I'm going to go ahead and trim all these leads in this section. Now that R1 through R10 are done, we'll do R12 through R21. These are also 620 ohm resistors. Now that all the 620 ohm resistors are soldered and their leads are trimmed, we'll move on to the next part. Next up, we're going to install the 1.3 kilo ohm resistors. And those colors are brown, orange, red, gold. And that will be R11, which is right up here. And then we have R34 through R44 and R33 through R32. So the only resistor that will be remaining once we finish with the 1.3 kilo ohm resistors is a little 1.5 kilo ohm resistor down here. Okay, so I'm going to install this resistor first, which is the current limiting resistor for the power LED, and then we'll go through and do these 2 rows of resistors next. Remember, it's all 1.3 kilo ohm. Colors are brown, orange, red, gold. Now all the 1.3 kilo ohm resistors are installed, so the last resistor to install is R22, which is 1.5 kilo ohms. The color code is brown, green, red, gold. Remember, when we place the part, we want to be able to read the value on the color code the same direction that we can read the value on the circuit board. That means gold will be on top. Now that all the resistors are installed, the next step is to install the sockets for the 2 integrated circuit chips. Those are IC1 and IC2 down here at the bottom. So this is an 8-pin IC, and then this is a 16-pin IC. And we want to put the socket in first. Now, reminder, do not install the chips at this time. We need to have some anti-static precautions when we install the chips. So for now, we're just going to solder in the sockets. Let's start with the 8-pin IC here at IC1. Now, when we install the socket, we need to make sure that we match the dimple on the silkscreen with the dimple that's on the socket. That dimple marks pin 1 as the lower left here. So we're going to take this little IC and we're going to drop it right in, making sure that all 8 pins fit nicely in, and then the circuit board and the socket should match up and sit flush. So the socket should sit flush against here. If you have a vise that includes a little part holder, then you can bring that part holder around and then have it hold the socket flush. But if you don't have a little parts holder like this, then I recommend using a small piece of masking tape. Take that little piece of tape and then press it down against all parts of the circuit board to help that part sit in place. Now that we're ready to solder this socket, what you want to do is solder 2 opposite corners and then check and make sure that the socket is still sitting flush. So let's solder these 2 opposite corners. Now that we have the 2 opposite corners soldered, let's turn this over. We can remove the tape and we'll confirm that the socket is sitting flush, which it is. And now we can solder the rest of the pins. Quick reminder that you do not need to trim the leads on these sockets. They're already nice and short. Now that the 8-pin socket is ready to go, we're going to repeat the process with the 16-pin socket. We'll insert it, making sure that we match up the dimple on the silkscreen with the dimple on the socket. And then same thing, we're going to either use the pad, if you have a pad to hold it down, or we're going to use a piece of masking tape. So here's my piece of masking tape ready to go. Same thing, I'm going to solder opposite corners here and here, and then I'll remove the tape and confirm that the socket is sitting flush. With opposite corners soldered and ready to go, let's peel off the tape and we'll confirm that the socket is sitting flush, which it is. and we're ready to solder all the rest of the pins. By the way, a quick note, when you have pads like this that are little ovals, a really easy way to do the soldering is apply the iron from one side of the oval and then feed the solder from the other. And then you want to make sure that the solder flows across the entire oval like that. So there we have it. Both sockets are fully soldered and ready to go. The next item to install is J2 and J3. These are female headers, and that's what we'll use to plug in the Arduino Nano once we're ready to power everything up. Now, these headers need to sit perpendicular to the board, and we need to be sure that they don't wobble. Now, you'll notice that they can actually wobble within the hole that receives them. Now, one option to keep these perpendicular while you solder them is take one out, do it one at a time, and then use the sponge, if you have that on your vise, to hold it perpendicular. And then in this method, you would do something similar with the socket, except you do one end and then the other, then confirm that it's still perpendicular to the board, in other words, going straight up and down on the board, and then you could solder the rest of the pins. But the best way to make sure that these two headers remain perpendicular while you solder them is to actually use the Arduino Nano as a spacer. So I'm going to take the little header, and then we're going to make sure all the pins line up, and then very gently plug it right into the pins that are on the Nano. And then we'll do the same thing on this side. So now the Nano is sitting here with the two headers connected. Coming back here to the circuit board, we'll make sure that the USB connector is facing the outside of the board, just like the silk screen represents. And now we can set the entire Uno with the sockets into the holes for the header. Now the Nano is going to hold everything perpendicular. Back to the masking tape then, we can use a piece of masking tape to hold the Arduino flush against the board while we do the soldering. Now what we're going to do is solder the ends. We'll do opposite corners and then opposite corners, then check and make sure the headers are completely flush, and then we'll do the rest of the pins. Now here what I've done is I've removed the masking tape now that the four corners are soldered, and I'm checking to make sure that both of the sockets, both of these headers, are sitting perpendicular to the circuit board. Now, after you solder the four corners, what do you do if you find out that the sockets are not sitting flush against the circuit board? Well, remember, we've only done the four corners, so that's fairly straightforward to correct. What you can do is take your soldering iron and heat up the pad for the pin that is not sitting flush. While you're heating it up, press gently on the opposite corner to allow it to seat properly into the circuit board. Take the iron away so the solder cools. And then if you do have to correct one corner, I recommend that you go around and do all four corners of that matter to make sure it's sitting completely flush. Then, once those four corners are sure to be flush, you can go through and solder all the rest of the pins. Now that you've fully soldered the two headers, I recommend that you remove the Arduino Nano. To remove it, what you want to do is gently pull up back and forth on both sides, rocking it up and down until it removes from the socket. Once you remove the Arduino from your board, be sure to set it back on its anti-static pad, and then we'll put it away for now. We won't be installing the Arduino Nano until the last step after we've checked everything else about our circuit board. The next step after J2 and J3, it's time for LEDs. We're going to install all of the red LEDs first, and then we'll install the green LEDs. So be sure that you only remove the red LEDs from their package. Now we can see that the red LEDs are LED 1, LED 12 through 21, and then LED 33 through 43. Now, you'll notice that the silk screen has the flat side of the LED symbol down towards the bottom. So that means that the short lead for all the LEDs will be facing down. All the LEDs all have the same orientation. Negative is the bottom pad on all of these. So ensure that when you insert the LEDs that the short lead is facing the flat side on the silkscreen. We'll insert both leads and then the LEDs will sit flush against the circuit board. In order to help the LED to stay flush, we can press it in with our finger and then pull the leads slightly away from each other so that will hold the part flush against the board. But since I have the sponge, I'm also going to use the sponge to also hold it flat. Now that the red power LED is ready to go, let's install the rest of the red LEDs. Now, in addition to them being numbered LED 12 through 21, you see I have the word red here printed in silkscreen for you. That tells you that this entire row will be red LEDs. The same is true for here. This entire row, starting with LED 33 all the way across to LED 43, is all red. So let's install all the red LEDs and then we'll go on to the next step. Now, while I'm here working on soldering these LEDs, I want to give you a little tip. I recommend soldering one lead on each LED and then going back and soldering the other lead. You'll notice that as I solder, the leads wiggle a little bit. So you don't want to have your other lead wiggle while the soldering is cooling. That can create a bad joint. So now that we have the bottom soldered, I'll go and solder the top and then I'll move on to another set of LEDs. You'll also notice I'm doing about 3 LEDs at once so that I can keep track of where I am and so that I don't have too many leads in the way. My top row of LEDs is ready to go. Reminder, before you trim any of the leads on the LEDs, double check and make sure that the flat portion of the bezel is facing down, which would be the same direction as the flat portion on the silkscreen silhouette. Now that the top row of red LEDs is ready to go, we'll do this row of red LEDs from LED 33 to LED 43. And don't forget that little red word right there gives us the hint on what color we're installing. Now that all the red LEDs are in place, we're ready to solder the green LEDs. That will be this entire row labeled green here on the top and this entire row labeled green here on the bottom. As you can see, our demonstrator board is coming along nicely. All the LEDs are in and ready to go. The next step will be the 4 capacitors, and we'll start with C1. C1 is a 0.1 microfarad capacitor. Sometimes parts like this capacitor will come still taped to their cardboard. So all you need to do is peel off the tape and then try to keep the leads from bending and wipe off any remaining adhesive that might be on the pins. Now, as you probably know, ceramic capacitors are not polarized. However, what we want to do is install the ceramic capacitor so that the codes printed on the body of the capacitor can be read the same direction as the silkscreen. So in other words, we're going to face the code towards the silkscreen for the value. Now with this capacitor, it has little shoulders on it that help it sit at the proper height. So we'll drop both leads and then allow the 2 leads to sit on their shoulders. So here we have the capacitor sitting ready to go. And as usual, while I hold it straight up and down, I'm going to bend the leads away from each other so that the capacitor will stay in place while we solder it. And you can see what I did in this case is I bent one lead opposite directions so that the part won't flop back and forth. Next up is C2. That goes here close to the LED for power. Now, C2 is a 220 microfarad electrolytic capacitor. Electrolytic capacitors are polarized, so we need to pay attention to the positive and negative. Now, this is my prototype circuit board, and I have the 2 leads sideways. I've changed this in my design so that now the negative pin will be facing down. But you can also notice that on the symbol is a little tiny plus. So when you're inserting the capacitor, make sure you put the long lead for the capacitor towards the pin that has the plus next to it. Now, depending on availability, your leads may or may not have a little shoulder for this electrolytic capacitor, but we're actually going to insert the capacitor so it sits flush upon the board. And remember, the long lead needs to go towards the positive symbol on the circuit board. So you can see here now it's sitting flush, and the same thing, we're going to bend the leads away from each other so that they hold onto the board. And now we'll go ahead and solder this part. Up next is C3, which is the 10 microfarad electrolytic capacitor. Now on this symbol as well, I've actually corrected this so that negative faces down. So remember, you want to make sure that you take a look at the positive symbol on your silk screen and install the long lead towards that. Also, another reminder, electrolytic capacitors like this also have a symbol along one side with arrows pointing towards the negative. So the lead with the white stripe going towards negative, that lead should go on the pin opposite of the positive symbol, right? Because that's the negative side. So in other words, the long lead needs to go into the hole marked with the positive. The short lead will go in the other hole. This capacitor also will sit flush against the circuit board. The last of our capacitors is C4, which will go right here between this resistor and the capacitor. And remember, we'll put the printing on the body of the part towards the value that's printed on the silk screen. This part also has that shoulder. Now with the ceramics, we're going to allow the capacitor to sit right on that shoulder. And we'll solder this last capacitor into place. Next items on our list are the two variable resistors labeled VR1 and VR2. You'll notice on the bottom of the variable resistor is a code, and that code gives us the value. So we need to be sure to double check these before we insert them in place. VR1 is a 10 kilo ohm resistor, which is code 103. And then VR2 is 100 kilo ohms, which is code 104. So be sure to double check them again before you put them in place. We'll start here with VR1, which is 10 kilo ohms, and again, code 103. Now the potentiometers that I use have two little clips that help hold this potentiometer in place, but it may not hold them firmly. So be sure to use a piece of masking tape, or if you have the little sponge, you can use that to hold the potentiometer in place. Or even if you have a separate pair of helping hands, you can use one of those clamps to hold it in place while you solder it. But make sure that it's sitting flush against the board before you apply the solder. Looking here at the bottom of the circuit board, you can see we have the two pads that are much larger that hold the two clips in place. And then we have the three contacts for the potentiometer. I recommend soldering the two clamps first, and then go and solder the three contacts themselves. So notice that the way that we solder this, we start by applying solder along the actual pin for the clamp that's going through the larger pad. Once the pin is soldered, then I filled in the rest of the pad with some additional solder to give it a nice firm connection. And we'll do the same thing on the other side. Now, as always, we're heating up the pad itself and the little pin going through the pad in order to melt the solder. Because this is a larger piece, it will take a longer time before you're able to heat up the solder to a proper temperature for it to melt. Okay, so now we have the two clamps soldered in place. We're going to wait for a moment to make sure the solder cools, and then we'll solder the three pins. Now that this potentiometer is fully soldered in place, we'll do the same thing with the other one. By the way, the pins on the two variable resistors do not need to be trimmed. With the two potentiometers in place, we're ready to install the two switches. S1 is a slide switch here for power, and then we have a push button here, which is S2 for switch 2. We'll start with the slide switch. Remember, when you place this part, make sure that the knob on the slide switch is facing the outer side of the circuit board. This inserts here. There's 4 outside pins for the chassis, and then the 3 contacts themselves. Make sure that you press it until it rests on the 4 outside pins. And remember, hold it in place with a clamp, masking tape, or a pair of helping hands so that it will stay firmly in place while you solder it. When soldering the slide switch, I recommend soldering the 4 outside pins for the frame and then solder the 3 inside connections. By the way, the pins for the switch do not need to be trimmed. Next up will be S2, which is the push button switch. Notice that the push button itself has a flat side. Make sure you line up the flat side of the push button with the flat side represented on the silk screen. If you rotate this 90 degrees accidentally, then the push button will not work. So you can see here that the flat side of the push button is facing towards the left. Now in this example, I'll use a piece of masking tape to hold the push button in place while I solder it. When soldering the push button, I recommend soldering opposite corners. Turn this over, and then we're going to make sure that the push button is sitting flush, and then make sure that you can actually push down and then you feel a little click when you push the push button. Next up is the barrel connector, J1. Make sure that when you insert this part, you'll notice that there's 3 pins, and of course the barrel needs to face the outside of the circuit board. I'll use my sponge to hold this one down, but of course you can use masking tape as another option. Quick note about the barrel connector. You can see here printed on the circuit board, the barrel connector is designed to receive 9 volts DC at least 600 milliamps of current. It has an inside dimension of 2.1 millimeters, outside dimension of 5.5 millimeters. This is the exact same requirements for the Arduino Uno power adapter. The last part that requires soldering is going to be our battery plug. Now, before we solder the 2 battery connections, we need to actually mount this entire holder to the circuit board, and we do that using the provided hardware. In order to mount the 9-volt battery socket to your circuit board, we're going to use the nylon number 2 hardware that's provided with your kit. Insert these 3 bolts through the top of the socket. They'll go through the socket and the circuit board, then attach the washers and then the 3 nuts from the bottom. Looking here from the bottom of the circuit board, I'm holding this bolt in place. I'm going to install the washer and then the little nut. To tighten this hardware, I'm going to use a flat blade screwdriver from the opposite side, hold it in place, and then we're just finger tightening these nuts. This hardware simply needs to be snug. Be careful not to over tighten. So here's what the installed battery socket looks like from the top of the circuit board with the 3 bolts going through. And here's what the battery socket hardware looks like from the bottom of the circuit board. Remember, even though the socket is fully mounted to the board, we still need to solder the 2 connections for the battery. And remember, the solder should fill in the entire pad and slightly climb up the lead. Don't forget to use flush cutters to trim the leads off of the battery connector. Now, before we install the two integrated circuits and put the Arduino Nano back onto the board, we have a little bit of housekeeping. First thing to do is to double check all the values on the board and make sure that each part is placed the proper direction. Make sure that the negative or flat side of all of your LEDs is facing the bottom of the board. Make sure that your capacitors are in the correct location, and make sure that your resistor values are correct. Once you double check the top side of the board, turn the circuit board over and double check all of your solder connections. Make sure every lead is trimmed. Make sure you don't have solder bridges, which is a bridge going between two different pads. Also check for any little bits of trimmed leads that may be laying across the board. Before we apply power, we definitely need to clean the flux from the bottom of the circuit board. If you used rosin core solder, then you can clean the flux with isopropyl alcohol or flux remover and a soft toothbrush. Make sure you clean up the entire board. If you used organic flux, then you can wash it with regular water and a toothbrush. But make sure you remove all the flux and be sure that your circuit board is completely dry before you apply power. Now that you've double checked all your parts, you made sure your leads are trimmed, and you've cleaned the flux from your circuit board, it's time to install the two chips. We need to observe some anti-static precautions, especially when we install the 4017 decade counter. Now, by anti-static precautions, we need to make sure that a difference in electrons does not develop between any two objects. There cannot be a buildup of electrons between the circuit board and the surface, between you and the parts, or even between the parts and the circuit board itself. To help keep that constant, we're going to use a static dissipative surface, and we need to follow some basic rules. Start by laying out the static dissipative bag and then place your circuit board on top of it, but leave some extra room for your other parts. As we lay down each part, it will make sure that electrons even out gently between these individual parts to prevent a static discharge that might cause damage. So we have our circuit board, and we're going to start with the 555 IC. Find the bag for your IC and then lay it on the dissipative bag as well. Now that your circuit board is laying on the static dissipative mat and your parts bag for the 555 timer is laying on this, make sure that you rest one hand on the bag as well. Once you do that, don't move in your chair. Ask if there's anyone else around. Make sure that they don't touch you or the surface, and make sure to keep any pets away. Now that we have electrons equaled out between all these parts, we will take the 555 IC out, and then we'll lay it in its internal bag right onto the surface. We'll unwrap this. And notice I'm resting my hands on the static dissipative mat as I do this to make sure no electrons build up. Okay. So here we have the IC, and any time you set something down that you're going to work on, set it on the silver dissipative mat. Here's the 555 IC, and I'll zoom in here for just a moment. I'm keeping one hand on the mat so that the static doesn't build up. And what we want to do is find pin 1 on the 555. Pin 1 is marked by a little dimple by the left corner. That little dimple in the corner would match the tip of your socket that also has the dimple in the middle. So I'm going to keep my hands rested on the static dissipative mat. We'll take the IC off of its little static dissipative foam pad that it's on. And now we're going to insert all the pins of the IC into the socket. Sometimes the lead on the IC may be spread apart slightly too far, so you can gently move the pins in just a little bit. All the pins should slide easily into the socket, and then place the IC straight down into the socket so it sits flush. Be sure to double check pin 1 on the 555. That's a little dimple in the lower corner. It should face towards the left. Now we're ready for our decade counter. We're going to repeat the process. I'll lay the circuit board here like this. I'm keeping one hand on the bag. I'll lay down the bag with the decade counter here. Now that I've laid the bag, I'll open the bag, and then I'll drop the internal container. So here's the 4017. Now in this, it's in a little tube. We just need to pull out one of the sides of the tube, and we'll take out the chip. Now when you're ready to insert the IC, set it right on top of the socket. Sometimes the pins on the IC, again, they may be opened a little wider than the socket will receive. So you can gently push the pins in just a little bit so that they can fit into the socket. And again, the IC should rest right into all the pins. Definitely don't force it in. Now that I've moved them all so they're all lined up, I'll press straight down. So here's a close-up on the two chips. We can see on the 4017 decade counter, it has that larger dimple on the edge, which it matches the silkscreen dimple. Don't be confused by this little circle in the middle. That is not marking pin 1. It's this larger oval here. On the 555, we have a little circle here, which again would be facing towards the left. We know that's pin 1 because that little dimple is off to the corner. The last two steps are to install the Arduino Nano and then put in the battery. For your Nano, remember the USB connector needs to face the outside of the board. Line up all the pins and gently press it into place. Before you install the battery, make sure that you've set your circuit board on a non-conductive surface. For instance, something that's plastic or wood, definitely not something metal. If you still have it on the static dissipative mat, make sure you take that dissipative mat away. We don't want any risk of a short circuit occurring on the bottom of the circuit board. Go ahead and take your 9-volt battery, place the negative side, which is the wider connector, towards the right, and then place the side with the contacts in first, and then drop it down into place so that it clicks into place. By the way, when you're ready to take your battery out, lift it from the back, put your thumb down here on the bottom, lift it from the back will lift out first, and then you can take it out. And now the moment of truth. Let's power up the demonstrator by flipping the power switch towards on. As soon as you give it power, a few different things are happening. The power LED should turn on and stay on. The top section of LEDs is controlled by the Arduino Nano. You can change the rate of the blinking by changing VR1. You could change the mode that the Arduino Nano is in by pressing the mode button. You can change the rate of the blinking LEDs on the bottom by moving variable resistor 2. Congratulations on completing your demonstrator soldering kit. Now it's time to share it with your friends and family. If you have any questions, feel free to contact me through my website, fvresearch.com.